So this is going to be the end of section 6.5, and it's going exactly backwards from what we just did. So the instructions ask us to write the expression as a single logarithm with only positive exponents. Each of the problems between 25 and 36 will have 2 or 3 or 4 logarithms being added or subtracted, all with the same base. And we're going to be asked to do the rules backwards and make the single logarithm, the multiple logarithm problem, into something that has one logarithm. Real easy to do. So to rewrite in a problem that has multiple logarithms as one logarithm, first thing I'm going to do is make any numbers in front of the logarithms, which are the coefficients, into exponents. That's just the reverse of what we did on our last step for the last group of problems. In the last group of problems, we made exponents coefficients. I'm trying to basically push these problems back to what they would have started with. So I'm going to rewrite problem 26 as the natural log of x to the 5th plus the natural log of y plus the natural log of z cubed. And now I'm going to write one logarithm with the appropriate base, and I need to put the x to the 5th, the y, and the z cubed in the correct places. Either we're going to multiply those letters or we're going to divide those letters. If there's a minus sign, the correct place would be in the denominator of a fraction. So if there's a minus in front of the log, the correct place will be in the denominator of a fraction. If there's no minuses, there's no fraction. So I think it's pretty obvious. Most students do really well on these. The correct place for these are all going to be multiplied together. When I put the letters back into the logarithm, the symbols are going to either be multiplication between the letters or division between the letters. And these 3 letters are going to wind up being multiplied. So I'm going to have an x to the 5th times y times z cubed. Because if you're going to take this and go backwards, the first thing you do to expand this, you'd write one logarithm with each letter. The signs between them would be pluses because the letters had times between them. And then you'd make the exponents into coefficients. So this would unwrap back into that. So my answer for problem 26, going backwards and taking the 3 logs to write them as one log, would be that. But I probably wouldn't have the times sign between. It probably, if I would have just written x to the 5th times y times z cubed, without the times sign, the times would still be implied. So I'm going to do exactly just backwards from our problems. Your problem 25 is a lot like this. Let me just do it real quickly. Your problem 25, the first thing you would do is you'd make the numbers in front of the logs into exponents. And then I'm going to write one logarithm because I asked to write a single logarithm. And you're going to put the x cubed and the y fourth in the right place. They can't be in the denominator of a fraction because there isn't a minus. So the right place is going to be multiplied next to each other. When I go backwards, pluses turn into times, minuses turn into fractions or divide. So that would be the answer for problem 25. I'll flash 27 up here real quickly because 27 is more like 26 than it is like 28. For what that's worth. So if you did 27, you still should watch me to do 28. For 28, I'm going to make the numbers in front of the logarithms into exponents in my goal to rewrite the problem that started with 2 logs into a problem that's equal to it that has 1 log. Now when I go to create 1 log, the only thing I can have is multiplication or fractions. And in this case, I'm going to get a fraction because the y has a minus in front of it. The y is going to wind up, or the y cubed is going to wind up in the denominator of the fraction. And the x squared is going to wind up in the numerator because it doesn't have a minus in front of it. This would be my answer to problem 28. And again, if you were given this problem and asked to expand it, the first thing you would do is write 1 log for the x squared, 1 log for the y cubed. The sign between them would be a minus because the y is in the denominator. Then you'd bring the 2 and make it in front of the x, the 3 and make it in front of the y. So we're just going backwards in some sense. This problem would expand to that problem. When we go to do problem 29 or 30, for my 30, I'm going to make the x have an exponent of 4. I'm going to make the y have an exponent of 2. And I'm going to make the z have an exponent of 3. Now I'm going to write 1 logarithm. And I have to decide where the x, the y, and the z go. The z has to be buried in the denominator of a fraction because it's after a minus sign. The only letter that ever winds up in the denominator of a fraction is a letter that's after a minus sign. Any other letter, if there's a fraction, has to wind up in the numerator. So both the x to the 4th and the y squared would wind up in the numerator. And this would be completely my answer for number 30. So this is rewriting a problem that had 3 logarithms down to a single logarithm. Your work for 29 should be similar. For 31 and 32, our problems are similar. Mine is base e, or it's ln. I'm going to start off rewriting the problem as the ln of x squared minus the ln of y to the 4th plus the ln of z. Now I'm going to make multiple logs, and this is super tricky. It might help you if I would have rewritten this problem as the ln of x squared plus the ln of z minus the ln of y to the 4th. I don't know if that makes it any more clear what I need to do or not. Ultimately, I need 1 logarithm. I know I need a fraction because there's a minus. And when I unravel from multiple logs into 1 logs, the only time I get a fraction is if there's a minus. And the only letter that goes in the denominator of the fraction is a letter that has a minus sign before it. So in my problem 32, the y to the 4th would be the only letter in the denominator. Both the x squared and the z are going to wind up in the numerator because there's not minuses in front of their logs. For problem 31, you'd start off by making this a log base 10 of x to the 4th minus the log base 10 of y squared minus the log base 10 of z cubed. When you go to write this as 1 logarithm, there's no rewriting you could do like I did to make it, pluses first and minuses second. You have 2 logarithms with minuses in front of them. Any letter whose logarithm has a minus in front of it, it's going to go in the denominator of a fraction. And when I'm shoving the letters into the fraction, I'm not getting any pluses or minus signs. I'm only getting divide signs, which are fractions, or times signs. The answer to your problem would be the logarithm of x to the 4th over y squared z cubed. And again, if you went backwards, you'd write 1 logarithm for each of the letters. The y and the z would get minus in front of them because they're in the denominator. The x wouldn't get any sign because it's written first. And then you'd make the numbers into coefficients. For your problem 33 and for my problem 34, it might help, it probably will help, if you write the logarithm with the minus last. That's always the nicest place for it, for me. So I'd probably rewrite 33 like that before I got started. And I'd probably write 34 like this, getting the terms with the minuses written last. Well, if I wrote the letters right, this should be the ln of y. So I'd whoa, it is actually right. Here, let me just pretend I know what I'm doing. And I would rewrite this, but I try to rewrite it properly. This I'm going to move to last, and these are going to be first. So I should have written the ln of y plus the ln of z minus the ln of x. Now I'm going to make one logarithm base ln. If I don't see a minus, I don't get a fraction. Because I see a minus, I get a fraction. The only argument or the only letter that would go in the denominator of the fraction is the letter that has a minus before it, which is the x. The other two letters don't have minuses before them, so they can't go in the denominator, hence they have to belong in the numerator. Inside the logarithm, the only signs I get are times or divide. The divide's a fraction. The times, I don't really even show a sign. I just write the letters next to each other. Your answer for 33 is going to be similar. So to do 36, well, maybe I can think of this as 4 ln of x plus 5 ln of z minus 2 ln of y. I don't know that that's really necessary, but if you like the minus written last, you certainly can do that. Then I can think of this as the ln of x to the fourth plus the ln of z to the fifth minus the ln of y squared, and make one logarithm. I see a minus, so I get a fraction. The only thing that goes in the denominator is the y squared, because that's the only logarithm that has a minus in front of it. Both the x to the fourth and the z to the fifth will wind up in the numerator. That would be my answer to 36. Your work for 35 is going to be similar. You don't need to rewrite it. The rest of the problems is using my calculator and the change of base formula, which we've done a bunch. And it says to round to 2 decimals, so I'm just going to play dumb and let my calculator do the rounding for me. So anytime I need to round to 2 decimals for a bunch of problems, I just hit the mode button, go down to the float area, change it to 2, hit enter. Now everything's going to round to 2 decimals. When I get done, I'm going to change it back to float. So for 38 on my calculator, I'm going to go log of 14 divided by log of 7. We've done a lot of change of base formula already, so real quickly, log of 14 divided by log of 7, and it'll round for 2 decimals. My answer is going to be 1.36 for problem 38. For problem 40, I'm going to do log of 36 divided by log of 9 and get 1.63. So nice that it's rounding for me, so you should be able to do 37 and 39. And then just a few more problems and this part of the video will be over. I almost could have stuck this on the last half of the video, but it was already so long I didn't want to do that. So for 42, it might be a nice number. Log of 0.25 divided by log of 2. I get negative 2. I don't have to write that as a decimal. My calculator, because it's in 2 decimal mode, is giving me the 2 decimals. I don't have to get them. And because this was a nice number, there'd have been a way to figure it out in my head. It would have been impressive, but it could have been done in my head. Well, it could have been in somebody's head, maybe not even mine. For 44, I'm just going to go log of 7 divided by log of 6 and get 1.09. So you should be able to do 41, 43, and 45. Once you get done with those, hit your mode button, go down to float, and hit enter to get the 2 toggled off so it's not going to always round to 2 decimals. Now my float is highlighted, and it will give me as many decimals as I need, just in case the next group of problems don't require 2 decimals. All right, just a few more sections, but we got some word problems coming up.